So second video in the root locus. In this video we're going to talk about the main important rules of drawing a root locus. To draw a root locus we're going to use the regular graph sheet. So I'll tell you. So the basic advantage of root locus is it is useful tool to find the system behavior when we are adding a pole or replacing a pole or moving a pole from one place to another place. Okay, so that's what the main advantage of the root locus. Root locus tells us the behavior of the system when we are moving a pole from one place to another place. Now here 1 plus k times gs, here k is a constant, varies from 0 to infinite. Okay, here is a system. Q indicates the zeros and P indicates the poles. Okay, so these are the rules, not the steps. Okay, you have to keep all these rules in your mind when you're drawing a root locus. So there are n lines. Those lines are called loci, where n is the degree of Q or P, whichever is greater. So Q is nothing but zeros, P is nothing but poles. So if a system has 2 zeros and 3 poles, then 2 zeros and 3 poles, so you have 3, you will have 3 locis. Loci is nothing but a line. Okay, so that's rule number 1. Okay, there will be n number of locis, n is nothing but the degree of Q or P, whichever is the highest. Okay, second rule, as k increases from 0 to infinity, okay, assuming k value is positive, then the roots move from the poles of the given system to zeros of the given system. Okay, so I mean in this class most probably my k value always positive number. So in this class, remember the loci is nothing but the line, always start at the pole and end at the 0. So basically I always represent pole with a cross, okay, and 0 with a 0. Okay, so here is a system. Here I have one pole and one 0. So loci, this line, loci is nothing but the line, always starts at the pole and ends at the 0. You will never see a loci starting at 0. You will see a loci always starting at pole, as long as k value is 0 to, k value is positive increase. So as I mentioned, in this class we will look into only positive increase. So always assume that starts at pole, ends at 0. Now same thing here. So here if you have number of poles greater than number of zeros, then you will have one loci there starting from pole ending at 0, another loci starting at pole ending at reaching to infinity, moving to infinity. I will talk about where to start the locis in the next point. So here if you have more number of zeros than poles, so I have 2 zeros and 1 pole, so we will end up having 2 locis. So always starts at one pole, another one is coming from infinity and reaching out to 0. So always remember loci always reaching to 0, always starting from the pole. Okay, another important rule, when roots are complex, then they always occur in a conjugate roots. Okay, so if say this system has 3 roots or 3 poles, one pole at origin, another pole is a complex. So if it is a complex pole, definitely you will end up having another complex pole, complex conjugate of the main pole. Okay, you will never see poles like this. Okay, so this is not possible. Always you will have a complex conjugate of poles. Okay, at any time some roots will never cross over its own path. So a loci going in this path is not possible because it's crossing over. This is not possible. So for example, here I have 2 poles. So one pole is coming, one loci is coming from there, another loci is coming from here. So these 2 locis reach here and they split, one going up, another one is going down. Now why not this Loki is going in another direction? Okay, so my point is, how come? So if you draw this again, I have two poles there. Why not this Loki is going in this direction, this Loki is going in this direction? That is explained in rule number 5. The position of the real axis to the left of an odd number of open loop poles are part of the Loki. So basically, you start from here and walk in this direction. Okay, you're going to start from here, walk towards left. Okay, if you see odd number of poles and zeros, there will be Loki. Even number of poles and zeros, there won't be any Loki. So if you're walking in this direction towards left, so this is one number of one pole. Okay, it doesn't matter pole or zero. Okay, that's one. So one is odd number, so definitely you will end up having Loki. Once you pass this point, I have one pole and one zero, so 2 is an even number, so there won't be any Loki on the left hand side of this 0. Same thing here. So we know that always Loki starts at the pole, so this is the pole, that's 0, so that's the reason in this direction. So here also same. Okay, start from here, always start from the left, start from the right, move towards left. Wherever you see an odd number, either pole or 0, there will be Loki. If it is 0, Loki is coming towards that 0, starting from the pole. Okay, same thing here. So start from here, move in this direction. So I have two poles. We know that Loki always starts at the pole, so Loki is starting from the pole. So what happens once it reaches somewhere? Need not be midpoint. We'll talk about it where it's going to split in the next rule. One line is going to go there, another line is going to go there. They're going to split. Okay, so here we have two poles on the right hand side. So 2 is an even number, so there is no Loki here in between. Okay, and here there will be Loki because we have 3 poles. Okay, whenever you say third. So you can see, so start from here, walking in this direction. So you see 1, that's a 0, so Loki is coming towards that 0 from this, starting from this pole. Okay, once you cross this, 2 is even number, so there is no Loki in this area. And again, that's 3, so 3 is the odd number, there will be Loki. Loki is nothing but a line, so it will start from pole, ends at 0. And the 4th, there is no Loki. And the 5th, yes, there is one. Okay, so another example, say for example you have something like this. Okay, so a pole there, a pole there, pole there. Okay, so here pole is nothing but Loki is going to start at the pole. So start walking from here, you will see, yes, there will be Loki. Okay, and that Loki is going to be, I mean, since that's a pole, it's going to start in that direction. And now here it's a, once we reach here, 3 is an even number, so definitely there is a Loki. So I'm assuming this Loki is going to go there. Okay, and there will be Loki starting from here, but I don't know which direction that Loki is starting because I need more information here. But for sure there will be Loki going in any one of those directions. Okay, but there is a Loki. Now lines leave, so rule number 6, so lines leaving is nothing but the breakout. So line leaving this main axis is nothing but the breakout point, and enter break-in point on the real axis at 90 degrees. So what I am saying here, so when I say here, these two Lokis are coming over there, right? They're going to touch to each other, and then they disperse that real axis at 90 degrees. So you will never see a Loki dispersing in this, I mean, less than 90 degrees. It may turn at one point, but definitely it is when it leaving that real axis, it is leaving at 90 degree angle. That's rule number 6. So breakout or entering is nothing but they're doing it in 90 degrees angle. Now, 7th rule, if there are not enough poles or zeros to make a pair, then the extra lines go to or come from infinity. So here in the first diagram, I have only one pole. Okay, so line is going to start. So always Loki is going to be, so if you stand here, start walking, whenever you see odd number of poles or zeros, you will see Loki. So when you cross this, that's the odd number, so you will have a Loki there. Okay, that's going towards infinity. Here also same thing. Here we have 2 poles but no zeros, so 2 Lokis. They are, splitting at 90 degrees. As long as there is odd number of poles and zeros, there is a Loki. Okay, but there is no zero, so those Loki is nothing but the line. That line is going towards infinity. So here there are 2 poles, so odd number once we pass this pole when you're walking from here towards left, so there is Loki, and those 2 lines might split, and one is entering there, another one is going towards infinity. Okay, now rule number 8, line go to the infinity along a asymptote. What is asymptote? Asymptote of a curve is a line such that the distance between a line and curve approaches to 0 as they go towards infinity. So as I mentioned, say for example, here is a Loki splitting. So assuming there are 2 poles, Loki is splitting here. So what happens here? A line goes to infinity. Say I'm assuming this line is going to infinity. So in that case, it's going to follow asymptote. Asymptote is nothing but that line and curve, they both are going to meet at infinity. Okay, the angle of asymptote, here is the angle of asymptote. I think you will understand better when I'm explaining this angle of asymptote while solving an example, but you can look into the equation here. Okay, angle of asymptote and centroid, those 2 are important points. I will talk about it in how to find centroid and angle of asymptote in the next video. Rule number 9, if there is at least 2 lines to infinity, then sum of all roots must be a constant. And rule number 10, k is going from 0 to minus infinity can be drawn by reversing rule number 5 and adding 180 degrees to asymptote angle. So if k is opposite direction, then your roots are going to be opposite side. That's what he's mentioning. Another important point, so these are the 10 rules we need to remember all the time. But another important point, the root locus is always symmetrical about real axis. So that means for sure, say if I have a root locus, so that's a x-axis, y-axis. Okay, say if I have root locus something like this. Okay, so that is on the above x-axis. Now below x-axis is going to be in the same way. So when I fold this paper on the x-axis, so it's going to be symmetrical on both sides. So yes, that's a good one. Maybe something like this. So if you have, then definitely you will have another Loki underneath that. So if you fold this page at x-axis, it will be asymmetrical. They both, it's not according to the drawing. So this is good. Or if you have something like this, for sure this is not root locus. Okay, you did something wrong, because when I fold this, we do not have this on this side. So this is not right graph. Okay, so I'll stop this video. These are the 10 rules. For sure, if you practice a couple of examples, you will end up learning all these things. I'm going to solve an example in the next video. Thank you.